A student project at Rowan University transformed a pile of cast-off computers into a virtual reality workstation built for speed. It not only processes data faster, it looks fast, like a cross between a jet cockpit and a motorbike. Science and technology correspondent Patrick Regan reports.
It's not a flight simulator or a custom job by Gloucester County choppers. This ride zoomed out of one of the semester-long multidisciplinary team projects that Rowan University calls engineering clinics straight into the virtual reality lab.
The principal work that we do here is to image various kinds of objects using ultrasound, X-ray, magnetic imaging, optical imaging, CAT scans. We take the data that we get from imaging objects, pass it through a virtual reality system, and try to predict the health of systems that we are imaging.
For example, one NASA-funded study here aims to integrate data from a sensor-studded test stand for a space shuttle engine.
VR allows for an immersive, interactive, and navigable experience of the entire data set.
But that immersive experience comes at a price in terms of processing power and time.
For a lot of your at-home computers, the kind of stuff we do could take 15 hours per individual image. And say we were making something for film, that's 30 images per second, taking an exorbitant amount of time to actually produce anything.
But the lab had the makings of a cluster of computers that could conquer such jobs by dividing them up and processing the parts in parallel.
We had 10 plus computers that were old, from a technology standpoint. So we originally thought we would just create a rack mount unit and just stick them in a cabinet somewhere.
But we wanted to build something integrated, very artistic, that shows that, engineers, we have an art side to us as well as mathematics.
I did a lot of the welding and bending and, metal work and such.
I focused mostly on the distributed computing side of it and actually connecting all the computers together to distribute the rendering process across them. And it's interesting to see the networking side of it because there's different styles of parallel processing. It's not just one common thing, you hook some cables up and it works. There's a lot more to it.
They say they had a blast creating a cool tool for the lab's tough jobs.
And we can produce these things much quicker without the downtime.
Patrick Regan, NJN News, Glassboro.